Hello, my name is Patricia Morales Bueno. I am a professor at Pontificia Universidad Católica del Perú, and I'm going to present the work Enhancement of Metacognitive and Scientific Practice Skills through the use of Gowin's Venn diagram, which is shared with Professor Rosario Santos Rodas. According to the OECD, scientific knowledge involves not only the content of science, but also its procedural and epistemic aspects. Scientific competence then implies the ability to explain scientific phenomena, interpret data, as well as evaluate scientific research and design forms of research. The skills related to these competencies need to be taught and explicitly modeled. Gowin's Venn diagram is a heuristic resource which is oriented towards the nature of knowledge, as well as that of learning, which allows it to be used both as an analysis strategy in the construction of scientific knowledge as in its reconstruction or learning. This tool interrelates the conceptual, procedural, and attitudinal competences of scientific activity and allows the integration of everyday knowledge with science. It includes the phases of the scientific method and allows to demonstrate the specific knowledge of the concepts, principles, and theories that guide the investigation. The shape of the diagram makes it possible to make explicit the relationships that exist between the conceptual aspects and the methodological procedures, based on the questions that integrate theoretical aspects with empirical or observational aspects. The diagram promotes that students be aware that knowledge is a product of research and that this occurs as a result of the interaction between the conceptual structure they have and the methodologies they choose in the task of building knowledge. This study reports the use of this strategy in a general chemistry laboratory course with the purpose of promoting the development of skills for scientific practice and metacognitive skills. The participants in this study were first-year students of basic sciences, physics and chemistry, from a Peruvian university. They were enrolled in a general chemistry laboratory course. The study included only students who responded to the metacognitive skills instrument applied as pre- and post-test. Thus, the number of participants was 11, whose ages were between 17 and 25 years. The average age was 19 years. All participants were male. The students were organized in permanent groups of 3 members. The design of the lab course considered 3 stages. The first one was a pre-lab stage, individual preparation stage that consisted of preparing an approach to Gowin's Venn diagram and developing some shared activities, such as reviewing some concepts related to the work session, looking for some physical properties of the substances to be used in the lab, as well as to do some simple calculations. The second stage was called Development of the Experimental Session. Students developed the lab experience following general guidelines that promoted inquiry and efficient management of the data collected. The teacher was a facilitator during this stage and promoted the academic discussion of what was being worked on. To do this, he used the structure of Gowin's Venn diagram and formulated the questions associated with it so that The working groups could elaborate proposals based on the evidence found in the experience and use of their reasoning. The groups could briefly discuss their proposals, thus providing opportunities for the use of their argumentation skills. The third stage was called report preparation. The working groups prepare their work report after the end of the lab session. This should be sent for review a week later. This report should include a Gowin's V diagram reviewed and agreed upon by the members of the working group. 3 variables were considered in this study. The first one, Gowin's V diagram. The students had to elaborate a first approach to this diagram individually as part of the stage prior to the lab session. After the lab session, the students elaborated a final diagram, reviewed and agreed by the working group. Both diagrams were evaluated with a rubric. The second variable was called scientific practice. This variable was constructed from the achievements assessment in the 3 stages of the lab course design. For this evaluation, a rubric was used. For both variables, the maximum score according to the rubric applied was 24 points. For the purposes of this study, this score has been expressed as a percentage. The third variable was called metacognitive skills. This variable was evaluated with the metacognitive activities inventory, 27 items that use a 5-level Likert scale with the purpose of exploring the use of the regulatory component of the metacognition, planning, monitoring, and evaluation in the context of solving university chemistry problems. The instrument was applied as pre- and post-test. The data were analyzed using a statistical package for social sciences 21 software. Level alpha was established a priori in 0.05. A descriptive analysis of the variable scores was performed. Correlation between the 3 variables was determined. Linear regression analysis was made. The dependent variable was MCA post-test score. The likely predictor variable considered was Gowin's V diagram score. The Wilcoxon signed rank test for related samples was used to verify differences between MCA pre-test and post-test scores. Table 1 shows descriptive statistics for total scores obtained in the 3 variables of study. Table 2 shows the Pearson correlation coefficients for the study variables. Only MCAI post-test scores were considered. There is a positive and significant correlation between Gowin's V diagram score and both MCAI post-test and scientific practice variables. This result proves that the strategy used had relevant effects on the improvement of metacognitive skills, since it promotes the students to use their skills and strategies for scientific experimentation in a reasoned and conscious way, especially those that allow the regulation of metacognitive activity. The correlation between the scientific practice variable and MCAI post-test score does not become significant. This may be due to the sample size as well as to the fact that the first one considers aspects that do not have a direct relationship with the metacognitive skills evaluated, such as those related to the format of the written report, the performance of previous activities between others. The results of the linear regression analysis indicated that Gowin's V diagram score was a predictive variable for the MCAI post-test. The 41.7% of the variance is explained by Gowin's V diagram score. The difference between the MCA pre- and post-test score was significant, so the strategy used has a significant positive effect on improving the students' metacognitive skills. The results obtained in this study are quite encouraging since it has been proven that a teaching and modeling strategy for the development of relevant scientific skills can have positive and significant achievements. The Gowin's V diagram could be an effective tool in this purpose if it is complemented by a facilitation work, since the use of this resource is difficult for the student with little experience. Further intervention by the facilitator is necessary at the beginning of the process, which will become less frequent as the student becomes more familiar with the use of the diagram. As shown, the strategy also promotes the development of metacognitive skills that constitute an essential component for the training of students, particularly in the training of future scientists. Thank you.